All right, section 3.5 continued. We are going to talk about the equations of parallel and perpendicular lines again. So, and we have a couple more theorems. Notice on this chapter we've had 14 theorems already, ladies and gentlemen. So, let's see. Theorem 313 says that the slopes of parallel lines in a coordinate plane, two distinct non-vertical lines, are parallel if and only if they have the same slope. So what they're telling us here is if we look here, again, our rise over run for this one would be the same as our rise over run for that one. And it would be, again, we're saying that their slopes are equal. So it's also saying these two vertical lines are parallel. So if we think about that, if we had a another xy plane here, and let's put the right one there. That will be y, and this one will be x. It is saying if we have two vertical lines, again, remember a vertical line would be going through, and remember both of them would say x is equal to something. So like x is equal to 2 and x is equal to 5. But again, since they're both vertical, we know that they would also be parallel. All right, that's for the slopes of parallel lines. They have equal slopes. And for the slopes of perpendicular lines, it says in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So in this case here, they're saying if I take them and I multiply them, right, I'm going to get when I multiply them, I should get -1, so their product is equal to -1. And they're saying also the same kind of thing here. If I have my x and y plane here, and they're saying if I have a vertical line and a horizontal line, right? Again, you should notice that they also are perpendicular. Again, this one here would say y equals. And this one here would be x equals. That's how we know that they're just, we all have a slope plus a y-intercept. So that's how you kind of know those ones. But again, we're going to look at two examples here, all right? So, a couple of examples. So, example 2, tell whether the lines through the given points are parallel, perpendicular, or neither. So again, what we have to do is we're going to have to find the slopes. So find the slopes. Remember, when I'm finding my slopes, I'm going to call them x1, y1, x2, y2. And our slope is, again, our rise over run. Which, again, would be our y2 minus y1. That's our rise. We're going up and down, right? And our run will be our x2 minus x1. All right, so now we're just going to plug in the ones we have there. So our y2 is 4, our y1 is 0, so we're subtracting them. And then I have my x2 is 7, and my x1 is -1. All right, so if we work that out, we'll get 4 on the top, we'll get 6 on the bottom. And remember, you can reduce that fraction. 2 goes into both of them. So if I divide 4 by 2, that'll give me 2. If I divide 6 by 2, that'll give me 3. So that's our one for line 1. So let's call that M1. All right. And now our M2, we're going to do the same thing. We're going to do x1, y1, x2, y2. And we're going to do the same thing. So y2 minus y1. So we're going to have 6 minus 0 over 3 minus 7. And if you look at that, we're going to have 6 over negative 4, which will, again, if I reduce that, that will give us negative 3/2. So as you can tell, the slopes aren't the same, but can you tell me, are they, if I multiply them? So if I take m2, or m1 times m2, so that'll give us 2/3 times negative 3/2. Again, if I multiply the tops, let's just go the easy way. If I multiply the tops, I get negative 6. If I multiply the bottoms, I get 6. I can reduce that fraction to negative 1. So since it is negative 1, we can say the lines are parallel. So the lines are, not parallel, perpendicular. Again, because their slopes, when multiplied, equal negative 1. All right? Let's do some more problems here. Now, some of these you've probably seen before in Algebra 1, so we're just kind of going through some more just like it. So you can also apply the theorems to write equations of parallel and perpendicular lines. So write an equation of the line passing through the point, negative 4 and 6, that is parallel to the line negative 3x plus y is equal to negative 4. I started to say y first because, again, we want to get it in slope-intercept form, where that means we're going to get the y by itself. So step 1, I just told you what it is. Put the equations into slope-intercept form. So what that is telling us is we have our slope-intercept form is y is equal to mx plus b. So that tells us that what we need to do is we need to take our negative 3x and we're going to move it over to the other side here. So it's going to become positive, and we're going to put it in front of the negative 4. So we can write that as y is equal to 3x minus 4. Okay? Now step 2. We know that parallel lines have the same slope. So for our next problem, we know that m is going to equal 3. All right? So we're going to write this now as y is equal to 3x plus b. Okay? Now you're going to find the y-intercept. By using m is equal to 3. And our point is an xy, remember? And in this case, it's going to be x is equal to negative 4 and y is equal to 6. So now I'm going to plug that in wherever I see y. So where I see y, I'm going to put in 6. Where I see x, I'm going to put in negative 4. And then we don't know what our y-intercept is or r plus b, all right? So when I work this out, I'll get 6 is equal to negative 12 plus b. To solve that for b, I'm going to take my negative 12 and I'm going to move it over to the other side. So that's going to become positive. So b is equal to 12 plus 6, which is equal to 18. So my line, that is parallel and through the point negative 4, 6, is y is equal to 3x plus 18. That's my final answer. Remember, when you're doing the work on the big ideas on your computer, you're going to have to put the y equals if they ask you to write the equation. All right, so we wrote the equation, and that's what you would have to put in. All right, so we need the equal sign and all that. Okay, so again, a couple more examples here. Example 2, write an equation of the line passing through the point negative 12 and 6. So again, just think that is my x and my y. That is perpendicular to the line y is equal to 2/3 x minus 10. So on this one here, it's already in slope-intercept form. So what we have to do is we have to find the one that is perpendicular to it. So step 1, find slope. Perpendicular to 2/3, right? Easiest way to do it is to take what you have and flip it. So we're going to flip it. That'll give us 3/2. And then we're going to make it negative. If it's negative, we're going to make it positive. This one here was positive, so we're going to make it negative. So our new slope is negative 3/2. All right. So again, we know that our new line is going to be y is equal to negative 3/2 x plus b. Now we're just going to do the same thing we just did for step 2. Okay, we're going to find the y-intercept. Again, since this time they gave us our point, all right, we're just going to plug it into our equation here. So y is 6 is equal to negative 3/2 times negative 12 plus b. And now we're going to solve that for b. All right, so let's see. I have 6 is equal to, now look here, I can take 12 divided by 2 will give me negative 6. So negative 3 times negative 6 gives me 18 plus b. All right, so now I'm going to subtract 18 on both sides. So if we do that in our head, that'll tell us that b is equal to 6 minus 18, which is negative 12. So our equation of our line that is perpendicular is y is equal to negative 3/2 x minus 12. And finally, our last one. Finally, recall from that the distance from a point to a line is the length of the perpendicular segment from the point to the line. So remember, that's the one where we gave you a couple of lines on a coordinate grid, and then we went from there and found that the shortest line is always from the point to the line is the perpendicular one. So let's go ahead and do this again. So we're going to go, let's start with step 1. Okay. So what we have to do is we have to find the equation of the perpendicular line passing through the point. All right. So remember, on this one here, our slope is 2, or if you want to think about it, it's 2 over 1. All right. So if our slope is 2 over 1, let me use a different color here. So it's going to be 2 over 1. Remember, our slope that is perpendicular to it will be, again, I'm going to flip it over. So it's 1/2, and then I'm going to negate it. So that makes it negative 1/2. All right. So then that tells us our y is equal to negative 1/2 x plus b. Now we're going to do kind of just what we just did with the other one. All right. So we are going to find that our point here, again, here's our x and our y. So we're going to put in negative 2 is equal to negative 1/2 times 6 plus b. All right. So if we work that out, we'll have negative 2. Half of 6 is 3, so negative 3 plus b. I'm going to add 3 to both sides. So I'll get that b is equal to negative 2 plus 3. It's going to be a positive 1. So we get y is equal to negative 1/2 x plus 1. Okay, that's step 1. Step 2, use the two equations to write and solve a system of equations to find the point where the two lines intersect. All right, so what we're going to do here is we're going to take our first equation. And what was our first equation? Y is equal to 2x minus 4. We're going to take our second equation, where we have y is equal to negative 1/2 x plus 1. And we're going to solve those. All right? So if you think about it here, if y equals 2x minus 4, and if y equals 1/2 x minus 1, we can say that they equal each other. All right? Again, I'll say it one more time. If y equals 2x minus 4 and y equals negative 1/2 x plus 1, we can say that they equal each other. So we can say that 2x minus 4 is equal to negative 1/2 x plus 1. Now let's just solve that for, solve that for x. All right, so what we're going to do is let's go ahead and add 1/2 x to both sides. And at the same time, let's go ahead and add 4 to both sides. You'll see that I'm still going to get the same thing. All right, so I will get that, well, 2 is, remember 2 I can write as 4/2. So 4/2 plus 1/2 gives us 5/2 x. And again, the minus 4 plus 4 goes away. And then I'll have 5 on the other side there. Okay, so now to get x by itself, let's go up here. I'm going to multiply both sides by the reciprocal. The reciprocal of 5/2 is 2/5. And if you think about it again, 5 divided by 5 gives me a 1. So I'll just have x is equal to 2. All right, so now we're going to plug in, into either equation, into 1 or 2. All right, well, I'm like you guys, I'm lazy. I'll use the one that doesn't have a fraction if I can. So I'll have 2, y is equal to 2 times 2 minus 4, which is 4 minus 4, which is equal to 0. All right, so our point then, because I said let's find the point where the two lines intersect. So our point where they intersect is 2 and 0. Right. You don't have to write that part. I was just reiterating what I told you. And then finally, step 3. So step 3. Use the distance formula. Oh, there we go. Using the distance formula again. To find the distance from 6 and negative 2, which was, again, up here, that was our original equation, right? And let me go back to the right thing. To our point we just found, which is 2 and 0. All right, so let's go ahead and do it the way I've been doing it with you. I'll take the second one. I'll take the first one. And then I'm going to subtract them. So 2 minus 6 is negative 4, right? And 0 minus a negative is positive. So 0 plus 2 is 2. So there's our, again, x2 minus x1 and our y2 minus y1. So now we're just going to use that and find our distance. Let's just call it d, is equal to, in this case, negative 4 squared plus 2 squared, which is the square root of 16 plus 4, which is the square root of 20. And again, if we plug that into our calculator, we would see that it is approximately 4.5 units. A lot of work, but we got the answer done, people. All right. Thank you.